Hello guys, today we are going to discuss about periodic table, and this is the essential topic on the IGCSE exam, official exam. So this is the topic 9, and today we are going to discuss about the part 1. So let's move the next slide and we will see the objectives and outcomes from this topic. Today, keywords are for this topic: periodicity, alkali metals, halogens, noble gases, group, period, metals, non-metals, and transition metals. We will discuss about them. The objectives are here. You can see to understand the term group, period, and recall the position of the metals, non-metals in the periodic table. And outcomes, you can check these outcomes to be successful in the official IGCSE exam. So now the main objectives are here. For part 1, describe periodic table as a method of classifying elements and its use the periodic properties of the elements, metallic, non-metallic properties, and how it changed across the periodic table, and relationship group 1, group number, and their outer shell electrons, metallic, non-metallic characteristics. And today we will also examine the group 1 elements and their properties and how you can interpret the data from the table or given graph to the tests. So if you are ready, we can start. This is the overview of the periodic table, and in the official exam also you will get the periodic table. And you can see in here key parts. Don't forget, if you forget in the exam, if you forget something and you don't know what's the periodic number, what's the atomic number, and how it can change the atomic mass. So look at these key points and you will see exactly where is for example, which number is atomic number and which number is a relative atomic mass. So, and the first question for you, let's check. Do you know what's a periodic table? And pause here and give your answer, then move to the next slide. So let's check the answer. Periodic table is a method of classifying elements. So this is the definition of the periodic table. And here we will see one structure of the atom, and we will talk about it, what's the main part and what's the subatomic particles in here. You can see in here main part, the nucleus. Nucleus consists of the protons and neutrons. We need to check their relative charges. So proton relative charge is positive 1 and neutron relative charge is 0, neutral. So their relative masses for proton 1, neutron 1. So that's why their sizes are here same. So you can see the blue and red balls, the size are approximately same. This is the charge, relative charge, and this is the relative mass. So what about this axis? In here, for example, how you can understand this? These are the electrons. So electron whiz around the nucleus and they are negative charged particles. So electron charge is 1, negative 1, and mass approximately we can take as a 0, we can neglect it, but you can write like this 1 over 1840. This is the relative mass. So you can see here again, this is the protons, neutrons cluster together in the center, forming the nucleus. This way, heavy part of an atom. And the electrons circle very fast around the nucleus at different energy levels. These are the energy levels, different energy levels. And these energy levels are called shells or orbits. So let's see the orbits. And electron arrangement, according to the shells, we can change. So we start to label the shells from the nucleus inner side. So this is the 1, this is the 2, and 3. We can label like this, and we can say this is the period 1, shell 1, shell 2, shell 3. And now let's discuss about how many electrons in these shells. Actually, we can count them. You can see in here 2 cross here. Okay, we can circle this axis. So in the first shell can hold up maximum 2 electrons. So we can write here 2 electrons maximum. But in here, second shell, let's circle the number of electrons. 1, 2, 3, 4, 5, 6, 7, and 8. We can write here. So second shell can hold up maximum 8 electrons. Let's move the shell third, but here different. We have some trick in here. Actually, in the third shell, we have 18 electrons. It can hold up maximum 18 electrons. But for the IGCSE exam, you know, the questions from the first 20 elements. So if the first 20 elements, from the first 20 elements, you don't need to learn the 18. You can say just the third shell can hold up maximum 8 electrons. But I am putting here cross because actually it is 18. But for exam, you can remember like this. First shell, 2, second shell, 2, third shell, 2, and fourth shell, you can remember like this 2 electrons. So we can see in here, this is a nucleus main part. The first shell can hold up maximum 2 electrons. It fills the first. Second shell can hold up 8 electrons. And you can see in here, again, actually is 18 electrons, but it can hold up for the first 20 elements 8 electrons. So the others goes to the next shells. Okay, so periodic table, let's see picture here. Now we will discuss more deeply about the periodic table. Periodic table arrange all the elements in group according to their property. So these vertical columns are called group. So these horizontal arrows called periods. So group, period, group, period. How is periodic table arranged? So pause the video and write your response, then let's check it. So let's check your answer. How is the periodic table arranged? You can see in here 2 versions. In official IGCSE exam, you can write both of them. The one in here, the elements are arranged in order to increasing atomic number. These place elements in vertical groups, columns, and horizontal periods, rows. Elements in the same period have same number of electron shells, and elements in same group have the same number of electrons in outer shell. We will discuss about it in the next slides. Let's discuss about groups. In the periodic table, how many groups we have? We said these the columns are called groups. And how many groups we have in periodic table? Actually, we have 8 groups. So you can see here, these are the group. So we can see here 1, 2, from here 3, 4, 5, 6, 7, 8. We have 8 group and we have 7 periods. In the exams, or some students confused to label the periods from this side, left side. They are starting from here 1, 2, 3, 4, 5, 6, and they said, for example, lithium in the first period. But you can see in here, this is a hydrogen and this is helium. So you need to start to label periodic periods from here 1, 2, 3, 4, 5, 6, and 7. So you can see lithium is not in the first period, lithium in the second period. So let's move the groups. We have 8 groups, 7 periods, and these are the main groups. You need to know their names. So group 1, you can call there as a group 1 element or alkali metals. Group 2 or alkali earth metals. Group 7, the halogens. Group 8, noble gases. You can see this is as a group 0. Why 0? We will discuss about it in the noble gases. Why they are 0. So you should remember these 4 groups. group 1, group 2, group 7 and 8, because we will discuss about their properties also. Let's see periodic table. Elements in the same group have same number of electrons in their outer shell. This corresponds to their group numbers. So I would like to write here, for example, group 1 elements lithium. So this is the number of electrons is 3, and here shells 2. We said first shell can hold up maximum 2 electrons, remain we need to write here. So this is the number of shells can state the number of periods. So how many shells we have? 1, 2. So this is lithium is the second period element. Then we can see here the outer shell, because here the number of electrons in outer shell. Outer shell is last shell. So last shell, how many electrons we have here? 1 electrons. So they are group number. Elements in the same group have same number of electrons in their outer shell. So let's see here. Example, all group 1 elements, then all group 1 metals have how many electrons in their outer shell? We said 1. If it's group 1, so here have 1 electrons. So let's see. This is group 1, group 2, group 3. So let me write here to see easily. Group 3. So these elements have how many electrons in outer shell? 3. Let's write here. Then these elements have 8 electrons or 0 electrons. It depends on we can write like this, 8 or 0. Because if we are discussing about the valence electrons, they don't have any valence electrons. I will discuss about later. So periodic table, as you move down through the periods, the extra electron shell is added. Why? Because number of shell increase, number of period increase, so we need to add more shells. Lithium has 3 electrons and configuration 2 and 1. We discussed about it. Sodium has 11 electrons in the configuration. So I said, do you remember? First shell can hold up maximum 2 electrons. Second shell can hold up maximum 8 electrons. So 2, 8. They remain how much? 11 minus 10, 1. So third shell can hold in here as just 1 electron. So how many shell we have? We have shell 1, 2, 3 shell we have. And outer shell, how many electrons we have? Just 1 electron. Let's find together. Potassium has 19 electrons in configuration. So we need to write the configuration. You know the rule. First shell can hold up how many electrons? 2. Correct. Let's write here 2. Then second shell hold up how much? 8. Great. Then I said these are the first 20 elements. 2, 8, 8, 2. Remember this rule? So how much in here? In the third shell? Guess 8. Great. And remain, let's count them together. 10, 18, remain how much? 1. So 1 electrons. So what's similarity for group 1 elements in here? You can see 1, 1, 1. In their outer shell have just 1 electron. So if they have 1 electrons in outer shell, these also state their group number. So they belongs to the group 1. So let's continue. The third fact, most of the elements are metals in a periodic table. Wow! Why? How we can find where is the metals and non-metals? Because this is important for the other topics. This zigzag line for us a boundary between metal and non-metal. You can see here red line. This is the border between the metals and non-metals. So this line divides the metals from the non-metals, and this part all called metals. These elements are metals, and these all called non-metals. So metals, non-metals. Metals on the left side of the periodic table, non-metals on the right side. Your turn. Let's read the question. Where are metals and non-metals found in the periodic table? Pause the video, then write your response. Let's check. Are you ready? So, metals make up most of the periodic table are found towards the left of the periodic table. Non-metals are found towards the top right of the periodic table. We discussed it. This is the correct answer. And how does metallic character change across a period? Your time, pause the video. So let's check your answer. Decreases across the period. Why? Because said metals on the left side, non-metals on the right. So next question for you. How does non-metallic character change across the period? Don't forget metals here, non-metals here. So pause the video. Let's check your question. Answer, sorry. It increases across the period. So because we said non-metals on the left side of the periodic table. So now we are discussing about the property of the metals and non-metals. Let's discuss how many of properties do you know belongs for metals and non-metals. You know from the checkpoint exams, maybe from grade 8. Let's see. You know metals properties. They are good conductor of heat and electricity. They are good conductor of heat and electricity, but non-metals, poor conductor. Metals, they are malleable. They can change the shape. Good. Metals, they are ductile. Yes, ductile, we can make the wires ductile. They are sonorous. We can hear the sound. Good. So let's focus on in here. Tends to be soluble. This is the characteristics of the metals. High melting and boiling points. Yes. Relatively low density. This is for group 1 elements. But for other metals, it's high. But for group 1, low density. Are shiny when polished. Good conductor of heat and electricity. They form positive ion in their compounds, for example, magnesium, and it's 0, but in magnesium oxide, it's positive 2, so it became positive ion. Basic oxides, you know, metal oxides are called also basic oxides, react with acid to give salt and water. It's a neutralization reaction. Now let's focus on the non-metals. Tend to have low melting and boiling point. Tend to be brittle as a solid. Brittle means easily we can break down them. Don't usually conduct electricity except graphite, carbon. So it's semiconductor. Poor conductor of heat. Tend to form negative ions. For example, let's say again magnesium oxide. Oxygen normally 0 as a molecule formula, and here minus 2. Tend to form a covalent compounds, you know, from the bonding topic, and non-metal between the non-metals occur covalent bond, and have oxides which are acidic or neutral. We discussed about this, acid and bases. So what's periodicity pattern? We need to discuss about. Have you asked this question? Why do elements in the same group have similar chemical properties? What's the reason of this? Okay, let's see. Because they have same number of electrons in their outer shell. We discussed the group 1 elements. For example, lithium. How much? 2, 1. So sodium, how much? 2, 8, 1. For potassium, how much? 2, 8, 8, 1. So in their outer shell have same number of electrons. So property is this. Because they have same number of electrons in their outer shell, they can lose only 1 electron. So if they can lose 1 electron, they are tend to act as a similar chemical properties. Now we are moving to discuss about the group 1 elements. And outcomes here for C or B or D. A, it's for your aims to get which grade in the official exam. These are the group 1 elements. So lithium, sodium, potassium, rubidium, cesium, and francium. This is the group 1. So all these elements are group 1 elements. It's better to remember the member of the group 1 elements, lithium, sodium, and potassium. You can remember these group elements. It's easier in the exam or other questions. You can guess easily the answer. Your turn. Which group do lithium, sodium, and potassium belong to? Pause the video and let's check your answer. Group 1 elements, yes. So periodic table, most important part, this is a fact 4. All of the elements in the same group have similar properties. This is how I thought of periodic table in the first place. This is called periodicity. So here, let's discuss about the property of the group 1 elements. You know, all metals have the common properties. They have good conductor of electricity, good conductor of the heat, and they are malleable, they are ductile, they are sonorous. But let's discuss here some differences also. Group 1 elements are soft. This is different than the all metals. Good conductor of heat and electricity, this is the common. Can be easily cut with knife, this is also differences. So we can cut these group 1 metals with knife, react with water vigorously, and they have low density. So your turn. What trends can be seen in group 1 elements? Lithium, sodium, and potassium. General trends. Okay, pause the video. So let's check your answer. All relatively soft metals, trend in melting point, trend in density, trend in reactivity with water. We will discuss about them. No worries. So group 1 elements, some facts. Let's discuss these facts. So density increases as you go down the group. So from top to bottom, density increases. While melting point decreases. So remember this trend. Density increase, melting point decrease from top to bottom. So they all react with water to form an alkali, hence their name, and example, for example, sodium hydroxide. Sodium hydroxide. So this is the general equation. Metal, group 1 metal plus water and metal hydroxide and hydrogen gas. For example, potassium plus water, potassium hydroxide and plus hydrogen, the product. So you can see example. And another trend in here, group 1 elements, softness. We discussed about density, top to bottom increase, melting and boiling point decrease, softness from top to bottom. When we are moving group down, it's also increase. Density increase and softness increase, only melting point and boiling point decreases. So your turn. How does melting point change down group 1? Pause the video. Let's check. Melting point decreases down the group because the strength of metallic bonds decreases, so less energy is required to break these bonds to turn the solid into a liquid. Your turn again. How does density change down group 1? Pause the video. Let's check your answer. Density increases down the group. All group 1 elements, have low density and will float on the water. So alkali metals, francium at the bottom of the group is radioactive, and also it's so active metal in the world. Pattern in the group, let's again summarize all patterns together. Melting and boiling points are relatively low and get lower as down the group lower. Don't forget. Density tends to increase down the group. Metals are very soft, became softer as we go down the group. So they are shiny silver when first cut, react quickly with air and water exposed into air. So they are so reactive they have to store away from the air and water, react quickly to form oxides, react violently with water vigorously to form a strong alkaline solution of metal hydroxide. We said as a potassium example, potassium plus water, potassium hydroxide and hydrogen. What's alkaline? Do you remember from the alkaline acids topic? So alkaline means soluble base. Now let's watch one video how they are more reactive.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present. Oh, thank you very much. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
OK.
Good luck. OK, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes!
Wow.
That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
OK, John, go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason, they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.
So it was an amazing video, and you saw how the first group metals are reactive. They react vigorously with water. So we will discuss about their also pattern, reactivity with water. All react with water to produce alkaline metal hydroxide and hydrogen. So general equation like this: metal plus water, metal hydroxide and hydrogen. The main difference is in the reaction is fast they happen. So when we are going to group top to the bottom, so reactivity increase with water. So they are react more vigorously with water. So increases reactivity with water moving down the group. Now your turn. What is the trend in the reactivity with water down group 1? Pause the video. Let's check your answer. Reactivity increases down the group. You saw in the video cesium and rubidium reaction. So cesium is more reactive than it was more reactive than the rubidium. So why do they react in similar way? We can discuss about this now. Actually, we discussed some part of this topic, but now we have time to discuss more about them. The lithium, sodium, and potassium. You can see they have all 1 electrons in their outer shell. So in the second shell 1 electron, in the third shell 1 electron, and in the last shell have 1 electrons. So if they have 1 electrons, they are have similar properties in group because they can lose 1 electron. And also we will discuss about how their reactivity change. For example, why from top to bottom reactivity increase. You can see in here, and this is the positive part, nucleus, and this is electron, negative. Negative attract the positive particle. So attraction force has occur between them. So you can see distances is less, so have more attraction force. It is not easy to lose this electron. It's a little bit challenging to lose this electron. We need to consume more energy to lose that electron. But in here, you can see a little bit far away from them. When we compare the lithium and sodium, sodium electron, the last shell electrons, is far away from the nucleus, so a little bit easier than the lose it. But when we focus on the potassium, you can see distances. And in here, attraction force is less. So that's why when we are moving in the group 1 from top to bottom, reactivity increase because for example, if potassium can lose easily its electron. Your turn. Why does reactivity increase down the group? Pause the video and write your response. So let's check your response. Group 1 element lose an electron when they react. Atomic radius and electron shielding increase down the group, so there is weaker attraction between nucleus and outer shell electron. This means less energy is required to remove this electron from elements further down the group. Is it clear? I mean, it's so clear, this part of the topic. Now your turn. Describe the general reaction of group 1 elements with water. Pause the video. Let's check your answer. Vigorous reaction with water producing hydrogen and alkaline solution or metal hydroxide. How we can observe the hydrogen gas in the process? Bubbles will soon due to the production of hydrogen gas. Now your turn. Use a trend in melting point. Predict which element in group 1 has highest melting point. So remember the trend, then apply the trend on this question. Pause the video. Let's check your response. Lithium, because we said from top to bottom melting point decrease, so highest should be in the top. This is the lithium. And next one, use the trend in density, predict which element group 1 has highest density. Remember the trend, then apply on this question. Pause the video. Let's check your response. This is the cesium. So we said density increase from top to bottom and highest should be in the bottom. Now, why they are so reactive? Because they are they have one electron in the outer shell. We need less energy to remove these electrons, and atom needs less energy to lose its electrons. So that's why they are reactive. In the reaction, group 1 atoms lose their outer electrons to gain the stable outer shell. It's easy, lose just one. Imagine that we are playing one games and we need to two team, and one group have one player and other, for example, we have 7. So it's easy to bring this 7 to near to the 1 or 1 to the 7. In here, it's easy to bring that the 1 to the near to the 7. So more shells there are further outer electrons from the positive nucleus, so the easier it is to lose. And then easier to lose an electron, the more reactive metal will be. So sodium chloride, you can see with the first group metals, when they lose 1 electron, this is atomic form, an atom. So it loses 1 electron, became positive ion. So sodium, this is ion. So atom turned to the ion. So electron transfer from the metal to the non-metal. This is also ionic bond, the structure of the sodium chloride. So that's it. This is the end of the lecture and the part 1. Next part will be 2 about periodic table. See you.